Hello. Good morning. I'm conceptualizing mathematics. I will weave some personal information in there too. That seems to really draw the crowd. But again, my motivation is to support all learners in mathematics. That's how I started out. I was only in academic intervention support for mathematics middle school level for maybe 1.5, 2 months, and then I was moved to Regents level, trigonometry and algebra 2 and pre-calculus. I picked up some 7th grade AIS because I did not want to leave it. It was near and dear to my heart. And then the next year, I was a 7th grade math teacher. But what happens when you're operating under regents and assessments and deadlines and calendars and holidays is you don't have time to do all the fun things you did when you sat at the table with the children in academic intervention support services. And you saw their eyes light up and you saw how much fun they had actually touching and moving and seeing the math come alive before their eyes, math that they created. So I'm going to stop there. So the question, I will repost that. Forgive me, whoever posted this initially, but it was one of these figure it out if a triangle has angle measures in the ratio of 4 to 3 to 2, what is the measure of the largest angle? And I tried to write how I might think of it conceptually, and now I want to parallel that with physical manipulatives. And as you can see, they're just household items. They don't need to be purchased. Nothing needs to be as expensive often as we make it. What do I know about a triangle? Now, I'm asking the children this if I'm in academic intervention support services or just in the classroom in general. And then we brainstorm, we jigsaw together. Actually, almost, I would say 75% of the time, my students were in cooperative learning groups. These were questions on the board posted to the groups, and I would have a stopwatch up on the smart board. They would have a certain amount of time to answer them collectively, and then we would report back out to the class in whole, but it would be jigsawed out, so every group had a chance to talk about it in a safe, more controlled environment, just with peers. And I would set those groups either homogeneously or heterogeneously, depending on my objective and who needed help where, and it was all strategic, and it was for a reason, a good reason. So anyhow, I would ask, and students might say, well, I know there's 3 angles and I know they add up to 180. Now, in that setting of academic intervention support, we would have fun things, so of course we would. And I would hope you would too in the classroom if you're able. So I built my triangle. I've got these little football skewers. And I built a triangle like we probably would often, most of us, just think about it, because that's what we see when we hear triangle. We just see an equilateral that's pretty symmetrical and uniform. And those footballs mark those angles. And next we would talk about what else we saw or heard in the problem. And a lot of times just that symbol, that colon symbol, cues us in that it's a ratio in mathematics, along with the language, right? We might know that a ratio is a comparison, and it talked about comparing 4 to 3 to 2. And we might also say, and again, this is as a learner coming up with this in their groups and me just writing it down on the board from what my kids are telling me. We came up with that a ratio has equal sized parts somehow. We know that, okay? So here we are, we're back to the problem, and I know that there was a 4 to 3 to 2. And so if we consider all those equal sized parts, there would be 4 plus 3 plus 2, there'd be 9 of them. Now I'm gonna go back to my triangle, and how would I get 9 angles out of 3? Well, I used my toothpicks to kind of show you. If I were to slice this angle, I'd have 1, 2, 3 angles, when originally I had 1. And most of us, if we were asked, would say, I know that one big angle in the beginning for an equilateral triangle was 60 degrees. Because there's 180 degrees and there's 3 angles, and when I divide 180 by 3, I get 60. Now I took that angle, that 60-degree angle, and I sliced it up into equal parts. So 1, 2, 3 angles. So I take 60 degrees, and if I divide it by 3, how much is in each of those baby angles? 20 degrees. 60 divided by 3 is 20. Now I'm paralleling this conceptual understanding to algebraic. So I had my 9 O's, or my 9 baby angles, were 180 together. I'm going to leave off the degrees. I'm going to leave off those units right now in my algebraic expressions and equations. So my baby angle equals 20. One baby angle I created was 20 degrees. The emphasis on I created, okay? Because once we do that, we understand that I can take those baby angles and make any triangle I want. I don't need the author of the problem. I don't need them to create a triangle in a 4:3:2 ratio. But since they did, I can use my 9 baby angles to create new triangles. And if I had more time, I would possibly in Math Lab or Math AS, I would ask them to create as many new baby angle triangles as you can using your 20-degree baby angles in different ways. Okay, remember they got to add up to 180. But in this example, and here's the beauty, and I'm going to pat myself on the back because I always told the kids you do that when you do a good job. I took my 9 baby angles, each 20 degrees, and I built a new triangle. And I used them in a way that simulated angle measures. There's my 4, there's my 2, and there's my 3. Now I have bigger skewers, not big enough, because what do you notice? Across from the biggest angle is the longest side. That's for another day. But back to our original problem, because we're discovering so much. How big is the largest angle? Yeah, I need more skewers to finish this triangle. But anyhow, to get the edges. Go back to the original problem. How big is the largest angle? Well, it's 4 baby angles, because the other one's only 2, and the other one's only 3. I didn't even need this model to demonstrate that. I could simply go back here and break up the 9 according to my problem, right? So I have 4 to 3 to 2. There's a physical representation of that ratio, 4 to 3 to 2. So obviously, because we're dealing with positive numbers for measurement, my 4 of something is going to be the most as compared to my 3 of something and my 2 of something. So I know it's this guy. Now I just have to come up with the amount. And we already figured out by slicing that 60-degree angle into 3 parts that each little part is 20. These are my little 20s. For 20s, I can count by 20s. 20, 40, 60, 80. Did not need this, but this would be my expansion. This is where I would go the next day if I were still in Math AIS. Shout out to you kiddies. Shout out to you teachers. Have a great school year. Make sure you bring in everything that's special to you and make lemonade out of lemons.